Fix the inputs and the outputs will fix themselves. This is James Clear. It reads to me as inputs and outputs can have a definitive calibrated relationship. Get the input right and you have the exact output you want. Functions are just that, quantitative relationships that are 100% predictable. Naturally, functions are at the heart of mathematics, capturing quantitative relationships for further manipulations and newer insights. In the previous reel, we had introduced two trigonometric functions, sine and cosine. We had mentioned that the two may just be treated as names of two functions in trigonometry. Let us explore sine and cosine and other functions that comes of it. Recall sine and cosine relate ratio of sides to a specific angle in right-angle triangles. The ratio of sides that is called the sine function of one of the two acute angles is called the cosine function of the other acute angle. Let us explore the functions. Functions mathematize relationships where every input has its own output. If we have an area function of a square, then side as an input to the function will give the area of the square as an output. Functions are usually defined as being one way, from inputs to outputs. However, they can also be utilized in reverse to determine inputs based on certain outputs. Technologies and innovations invariably use functions. All kinds of system controls are functions. Circuit cutoff due to higher than threshold temperature in some process or equipment is an example of a function that takes temperature as input and outputs a mechanical cutoff action or an electrical impulse that cuts off the circuit. Functions translate dynamic, real-world situations and conditions into mathematical expressions. Functions that quantify sides and angles relationship are called trigonometric functions. We say that we apply a function on an angle to get a ratio that is two numbers in a direct relationship as the output. That ratio of numbers is a definite ratio of sides of a right triangle, of which the angle is one of the two acute angles. Sine and cosine are examples of trigonometric functions. And yes, you must be proud of self to be instinctively thinking about the bias in naming what are regarded as trigonometric functions. Why angle to ratio conversion is function, and the ratio to angle conversion the inverse of such functions. Why it cannot be the other way round, calling ratio of sides to angle conversions as the trigonometric functions, and not call them inverse trigonometric functions. There is an interesting fact and reason for the choice of what is trigonometric function. Simply, it is more useful that way. We take angle to ratio conversion as the function because this is the more common need. It makes more sense to see the angles as ratios rather than degrees. Ratio is much more obvious and simpler to visualize, use, and of great practical importance. For instance, in USA, the Americans with Disabilities Act, ADA, lays down the specifications of the curb ramps to be no more than 1:12 in rise to horizontal distance ratio, or a maximum of 8.33 degrees slope. Which of the two quantities is closer to popular visualization, 1:12 or 8.33 degrees? 1:12 is simpler to me. By the way, at 1:12, the best ramp is the angle is 4.76 degrees. How does one even get that angle right in constructing 1:12? To cite another example, it is far more relatable and easier to register or compare the ratio of the height of two things and their respective shadow lengths under the sun than to try see if the angle of the sun rays are similar. The advantage of ratios over angle measures is also why textbooks call this relationship as trigonometric ratios. We apply trigonometric functions on an angle of a right-angle triangle to get a ratio of length of sides of a triangle as output. This ratio is of specific sides. The ratio of length of sides calls for a reminder Ratios are always written in their simplest form, that is, by reducing all the common factors. For example, if a ratio is found to be 12:6, in reality it would be expressed as 2:1, and not as 12:6 or 4:2. The logical advantage of expressing ratios like that is for another real. Thus, in trigonometry, the ratio of sides as the outcome of using trigonometric functions on angles is not the ratio of the actual lengths of the sides of the right-angled triangle. In the picture, the same angle A could be part of any of the 4 triangles and infinite more. But the ratio of the sides will be the same for all of those triangles. But how could we know the actual length of sides of a right-angled triangle once we know the ratios? We would need to know the actual length of one side to actualize the ratios. For example, if we know the ratio of sides, that is 2:1, and one side in the ratio 16:x, then x will be 8. Let us get back to the ratios and angles of a right-angled triangle. There are 6 ratios of sides and 2 acute angles. The other angle is fixed at 90 degrees. H by O is the reciprocal of O by H. Similarly, H by A is the reciprocal of A by H, and A by O is the reciprocal of O by A. The trigonometric functions of an angle that give the 3 ratios, O by H, A by H, and O by A, are primary trigonometric functions. The trigonometric functions of an angle that give the 3 reciprocal ratios, H by O, H by A, and A by O, are multiplicative inverse trigonometric functions. The primary trigonometric functions of angle P are sine of angle P, cosine of angle P, and tangent of angle P. The primary trigonometric functions of angle Q are sine of angle Q, cosine of angle Q, and tangent of angle Q. Sine is a primary trigonometric function of angle P, which gives the ratio of sides as O by H. Cosecant is the multiplicative inverse trigonometric function of sine, which gives the reciprocal of ratio of sides, that is H by O. Cosine is a primary trigonometric function of angle P, which gives the ratio of sides as A by H. Secant is the multiplicative inverse trigonometric function of cosine, which gives the reciprocal of ratio of sides, that is H by A. Tangent is a primary trigonometric function of angle P, which gives the ratio of sides as O by A. Cotangent is the multiplicative inverse trigonometric function of tangent, which gives the reciprocal of ratio of sides, that is A by O. To some, same ratios mean different for the 2 acute angles of the right-angled triangle. The ratio of sides, that is called the sine function, of one of the 2 acute angles is called the cosine function of the other acute angle. Take sine, cosine, tangent, etc. as just the names of functions for now. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.